Hello, I'm on site here at Embedded World 2026 on the DigiKey booth, and I'm pleased today to be joined by Erik and Greg from Octavo Systems. And today we're going to be talking about the OSD62X-PM system in package. So before we start, would you like to introduce yourselves, Greg? Perhaps we'll start with you.
Yeah, hi. I'm Greg Sheridan. I am the Vice President of Strategy and Product at Octavo Systems.
Fantastic. Erik?
I'm Erik Welsh. I am the Chief Technical Officer at Octavo Systems, and I run our engineering teams.
Fantastic. Could one of you also introduce the company for us as well? Tell us a little bit about who you are and what you do.
Yeah, so we are Octavo Systems. We are a system and package company, which is basically the next generation of modules and SOMs. So basically what we do is we integrate the kind of some complex parts of a embedded system, mainly your microprocessor, your DDR4, up to power management, eMMC. We take all of that and integrate it all into what is a single IC package. Mm-hmm. So if we look kind of some of our products, like the OSD62 that we're talking about today, we basically have processor, DDR, and 40 passives all in this single IC device. So making it easier for people to design with, significantly reducing the size, so we're about 70% smaller, and then reducing the total cost of ownership over the lifetime of the product as well.
Fantastic. So let's dive into some of those features you've mentioned. So this integrates the Texas Instruments AM62X processor, as you said, DDR4 memory, key passives into a very small footprint, so 9 by 14 millimeter package. Mm-hmm. But how does it fundamentally change what engineers can build with the AM62X platform?
So one of the things that's really great about the 62 processor module is really the fact that because of this integration, you're able to have 4-layer printed circuit board designs. Okay. So really, most of the time with the DDR and everything like that, you're at least in 6 layers just because of the complexity from a routing perspective and everything. So really, when you have this level of integration, you're able to go in and have much nicer printed circuit board designs. And so we have a number of open hardware reference designs like this BRK board. Mm-hmm. This allows us to have a reference on the power management, as well as access to all the different peripherals and everything associated with the device. And so really, the integration enables you a lot faster time to market, a lot simpler PCB design rules, and you don't have to go and solve a problem that's already been solved. DDR is a solved problem. I mean, but every time we do a new product, we have to go solve that problem again. And really the use of things like system and package allow us to push technology a lot faster and a lot farther because you don't have to worry about these solved problems.
Fantastic. And sorry.
I was going to say, it really lets them put this, the power of the AM62 into newer, smaller form factors, right? In areas that you couldn't have gone before. Yeah. And then again, allows you to do it so much faster. Yeah. So you can iterate faster and get more product out and spend more time focused on what's going to differentiate your product and, to what Erik said, solve a problem that's already been solved.
Yeah. Well, that leads me nicely on to my next question. With this smaller footprint, which new classes of space-constrained applications or product designs do you see becoming possible?
Yeah, I mean, this is where, again, it's really interesting and really cool to be at shows like this where you can kind of see and talk to customers about where they're trying and where they're looking at this stuff. I mean, wearables, AR glasses, right? You see that is really becoming big, so there's a lot of that kind of stuff. Robotics is a big space. I mean, you think about trying to reduce weights of arms so that way your motor can lift more and stuff like that. Mm-hmm. This kind of solution is really great in those types of things.
And more moving stuff more to the edge. I mean, it's like as you get these smaller, ruggedized form factors that you need in order to be able to get the product out towards the edge, this system and package really helps facilitate that because, I mean, at the end of the day, it's all a standard IC, it's all molded plastic, and so you're able to now have the ruggedization of these components alongside the fact that you're able to integrate a lot more together and have these nice small form factors. So it makes it easier to put them in places that you might not otherwise have thought, like moving it to the actual actuators and motors on the robot, so that way you have smarts at local and a lot more local processing in form factors that you wouldn't have otherwise had.
And it actually comes in cheaper than what most engineers can source and build discrete, right? Which I think surprises some people. So what factors make this so cost effective, and how do you see this changing perceptions in industry?
Yeah, that's actually one of the things we're most excited about for this product, right? Is a lot of times when people look at integration like this, they're like, okay, how much is this going to cost me? And we're really excited over basically our 10 years of doing this kind of stuff, working on our manufacturing processes, our design process, working with our supply chain, as we are actually able to get this product down to a lower cost than if you were going to go buy the processor, the DDR, the passives yourself. You're actually going to pay more than just buying our system and package, and you get all the benefits that system and package comes along with it. So again, it's really, a testament to Erik and his team and the design and how they've been able to go about that, and the relationships that we have with Texas Instruments and the different memory suppliers and stuff like that.
And one of the other claims I've got here is that it can shave off 3 to 6 months off a design cycle, which could save around 500K or more. I mean, how true is that?
Well, it's very true because, I mean, again, like we said, DDR is this solved problem, but it's a hard problem to solve. And really, I mean, if you look at the engineering time spent solving that problem and then going through and trying to then make sure that you validate it, that's probably saves you at least a board spin. I mean, just having a known good solution that you can put down on your PCB and go with that. So having that known good solution saves you at least the PCB design spin, which is a significant amount of time for most customers. And then you've solved the problem of your DDR routing. And you have nice examples of how to do all of your power management and everything like that. So it really does speed up that design process because it allows you to focus on the things that differentiate your product, not these things that are table stakes. You're never going to put that you got the DDR working on the packaging on the box. That's just not something that customers really care about. They want to know what features differentiate your product, and that's what the system and package allows you to focus on.
And I also understand there's a flexible open development platform. Can you tell us more about that?
Correct. So what we did with the 62PM BRK is basically we show you how to have access to all the different I/O. So we basically set it up so that you have your storage with your SD card, you have your processor and DDR, you have your power management, and then these headers allow you access to all the I/O. So you have access to all the Ethernet ports, all the other I/O that you might want to go prototype with. And so this is really a nice small form factor. This is like 1.2 inches by 4 inches. And so you can take this and really start looking at how do you want to use this in your system. It's also Microelectronica Click compatible, so you can buy off-the-shelf boards from Microelectronica and plug those in on either end in order to be able to add functionality seamlessly. It works with all of the the TI software ecosystem, so the TI SDK as well as all of the Code Composer Studio tool chains and everything. So you're able to go through, leverage all the existing software infrastructure and get started and prototype your design very efficiently and effectively.
And it is completely open source. So all of the schematics, layouts, design files, everything is all available on our website, completely free. So it really is a great starting point. You buy it, you prototype your board, and then you take that as your kind of starting point from schematics and change them around and just go from there.
Excellent. And what about your partnership with DigiKey? How has that changed accessibility, support, and adoption for your customers?
Yeah, I think DigiKey was really one of the first distributor that we worked with, right? And it was really key to us because our whole thing is trying to make it easier for customers to accomplish their goals and to build their products, get access to these technologies. And really, DigiKey is the premier supplier, right? And having stuff ready to go, readily available, quick. And then the support that you guys can also provide. So really working with DigiKey just really helped, continue to grow our value proposition, or really what we're trying to do is just make it easier for our customers. You guys take all the complications of getting and ordering the products, right? You can buy ones to hundreds of thousands of the products. So it's been really nice. Just open it up, allow us to reach such a bigger audience and let them get hands on this technology.
Excellent, good to hear. So finally then, what's next? Have you got anything else coming up down the pipeline?
So the next generation, so we've worked with TI a lot on different types of processor modules. We are looking at doing a fully featured integration with that. So we're looking at, from a 6.2 perspective, integrating the power management into a fully featured SIP. But first, before that, we also have a partnership with ST Microelectronics. And so we are looking at coming out with an MP2 processor module. So basically, it uses the same type of technology that we use in the 6.2 processor module. And now we're going to use the MP2 processor from ST, along with up to 4 gigabytes of DDR4 in that same 9mm by 14mm form factor.
Fantastic. Well, Erik and Greg, thank you so much for taking the time to speak with me, and I hope you enjoy the rest of the show.
Well, thank you very much.
Thank you.